Have you ever looked up at the moon and wondered what it would be like to see it being born? To watch that familiar silver face emerge from cosmic chaos? To witness the moment when Earth gained its eternal companion? Can you imagine standing on the early Earth, feeling the ground tremble as another planet approaches through space? What would you hear in those final moments? The groaning of a world under gravitational stress? What would the sky look like as Theia, a planet the size of Mars, grew larger and larger overhead? How would it feel to float within the very debris that would become our moon? To watch billions of fragments slowly gather together, pulled by invisible forces into the sphere we see tonight? If journeys through deep time bring you the same wonder they bring me, if you find peace in these ancient memories, please consider liking and subscribing to follow along for more. And if someone you care about might appreciate drifting through Earth's memories as they drift off to sleep, why not share this gift of wonder with them? I'd love to know where in the world you're listening from tonight, and what time you're settling in for this journey. Leave a comment below. Let me know what corner of our modern Earth you call home. And if there are other moments in deep time you'd like to explore together, other ancient memories you'd like me to share, tell me in the comments. Your suggestions guide our future travels. But for now, let's leave the modern world behind. Welcome back, fellow traveler of time. Are you ready to step once more into the flow of memory, to witness a moment that shaped everything that came after? I want to share with you tonight a memory so profound, so transformative, that it changed the very nature of what it means to be a planet with a companion. This is not just the story of how our moon was born. This is the story of how Earth itself was reborn, transformed through cosmic alchemy into something entirely new. 4.5 billion years ago, in the cosmic nursery of our young solar system, two worlds danced a fatal waltz that would echo through all the ages to come. Tonight, I invite you to experience this dance not as distant history, but as living memory, to feel the approach of Theia, to witness the moment of contact, to float within the very debris that would become our silvery companion. Settle in now. Let the weight of your day become a distant memory. Breathe in the quiet of your room, and with your exhale, let the present moment gently drift away. We are not bound by clocks or calendars tonight. Together, we will step outside of time to a place I remember well, a world waiting in the deep past. I am the Chrononaut, and I have drifted through the ages like smoke through still air. Tonight, I invite you to join me on a journey, not forward, not back, but deeper, into the memory of Earth itself. Close your eyes if you haven't already. Feel yourself becoming lighter, untethered from this moment, ready to slip between the seconds and find yourself in a time before time was counted. Come with me now. Let us cross the threshold together. We are traveling now, back through the millennia, back through the epochs. Feel the years falling away like autumn leaves. Humanity's entire history passes in an eye blink. The ice ages roll backward. The continents merge and separate and merge again. Life itself retreats to the seas, then to simple cells, then to nothing at all. Deeper still we go, past the formation of Earth's oceans, past the cooling of its surface. We arrive in the Hadean Eon, that time of fire and fury when Earth was still learning how to be a world. 4.5 billion years before your time, when the solar system itself was young. Open your inner eyes now. You float with me in the void between worlds, and what a sight greets us. I remember the approach. For months, years, perhaps decades, I watched Theia draw closer. She was magnificent in her approach. a world the size of Mars, wrapped in her own atmosphere, carrying her own secrets, her own possibilities. Let me take you back to those early days of watching, when Theia was still just a brightening star in Earth's turbulent skies. The young Earth spun so much faster then. A day lasting only 5 or 6 hours, the sky wheeled overhead in a dizzying dance, stars streaking across the heavens, the distant sun racing from horizon to horizon. But one light did not follow the dance. One light grew steadily brighter, night after night, refusing to follow the orderly procession of stars. That was Theia, and I watched her approach with the patience of eternity. In those early days, she appeared as just another point of light, indistinguishable from the countless stars that populated the young universe. But as the weeks passed, she began to show her true nature. First, she developed a disk, no longer a point, but a tiny circle of light. Then features began to emerge: cloud bands, the glint of possible ice, the dull red glow of her own volcanic activity. I remember floating high in Earth's atmosphere, watching both worlds as they drew together. Earth below me churned with its own violence, a planet still learning how to be a planet. Volcanoes erupted continuously, painting the sky with ash and sulfur. The atmosphere was thick with methane, ammonia, and water vapor, creating a greenhouse so intense that the surface glowed with its own heat. And above, growing larger with each passing day, Theia approached. She had her own story, her own journey through the early solar system. Born perhaps in the same region as Earth, perhaps elsewhere, and captured by the complex gravitational dynamics of the forming planets. She carried within her the same materials that built Earth: iron and nickel in her core, silicates in her mantle, volatiles in her atmosphere. As she drew closer, her gravitational influence began to make itself known. Earth's already violent surface became even more agitated. Earthquakes rippled across the planet continuously. Volcanoes that had been dormant for years suddenly roared back to life. The very shape of Earth began to deform, pulled by Theia's gravity into an egg-like ellipsoid. She was a dancer approaching her partner, each movement precisely calculated by the laws of gravity and momentum. As she drew closer, I could see her surface in exquisite detail: mountains and valleys, perhaps even the glint of frozen volatiles at her poles. I want you to imagine what it was like to witness this approach from Earth's surface. Picture yourself standing on a volcanic plain, the ground beneath your feet still warm from recent lava flows. The air shimmers with heat, thick and difficult to breathe, even if you had lungs that could process it. Above you, the sky is a tapestry of colors no human has ever seen. Deep reds and oranges from the methane, streaks of yellow from sulfur compounds, and through it all, growing ever larger, the pale disk of approaching Theia. At first, she would have been visible only at certain times, following her own orbit around the sun. But as the two worlds spiraled closer together, trapped in their mutual gravitational embrace, she became a constant presence. Day or night, she was there, growing larger, growing closer. I remember one particular moment, perhaps a year before impact, when Theia first appeared larger than any star, larger even than Venus appears in our modern sky. She had crossed some invisible threshold from celestial object to approaching world. On Earth's surface, the tides she raised were beginning to become noticeable. Not water tides, for Earth had no oceans yet, but tides in the molten rock itself. The solid surface rose and fell with her passage, groaning and cracking under the strain. The sound was extraordinary, Not just the constant rumble of earthquakes and volcanoes, but new sounds. The deep, resonant creaking of a planet under gravitational stress. Low-frequency waves that you felt more than heard, passing through the ground, through the air, through everything. Earth was singing a song of approaching destiny, and Theia sang back in harmony. As months turned to weeks, and weeks to days, the dance accelerated. Theia now appeared as large as our modern moon, but growing visibly larger with each orbit. She was no longer following a simple path, but was caught in a complex spiral, her orbit decaying with each pass. Sometimes she would approach close enough that you could see features on her surface with naked eyes, if anyone had possessed eyes to see. I spent those final weeks moving between worlds, experiencing the approach from both perspectives. From Theia's surface, Earth loomed enormous, a swirling ball of fire and cloud that filled half the sky. The gravitational tides were even more extreme here on the smaller world. Theia's surface cracked and reformed constantly, her own volcanism triggered by the tidal heating. The smaller world was dying even before the impact. Pulled and stretched by Earth's gravity, her interior heated beyond endurance. Her atmosphere began to stream away, pulled toward Earth in great spirals of gas that connected the two worlds. In those final days, they were already beginning to merge, already beginning the process that would unite them forever. The sound was not what you might expect. In the vacuum between worlds, there was no medium to carry ordinary sound waves, but the gravitational waves, those I could feel. Each world was ringing like a bell, vibrating at frequencies far below human hearing. These vibrations passed through space itself, distorting the very fabric of reality. I remember the colors of those final days. Theia's atmosphere heated by friction as it scraped against Earth's outer gases, glowed in shades of pink and orange. Auroras danced between the two worlds, charged particles spiraling along magnetic field lines that now connected them. Lightning played constantly in the space between, fed by the electrical potential differences. In the final hours, Theia filled a third of Earth's sky. She was no longer a distant world, but a looming presence, her mountains and valleys visible in stark detail. I could see landslides on her surface, triggered by the extreme tides. Entire mountain ranges were crumbling, pulled apart by forces that exceeded the strength of solid rock. Earth's rotation had slowed, its days stretched by Theia's pull. The smaller world orbited now just outside what we would call the Roche limit, that invisible boundary where tidal forces become stronger than self-gravity. Let me explain what this means in visceral terms. For the Roche limit is one of nature's most dramatic boundaries. Inside this limit, no moon can exist. Tidal forces tear apart any would-be satellite, reducing it to a ring of debris. Theia danced just outside this boundary, close enough that she was beginning to deform, but not so close that she would be destroyed. Yet, the deformation was visible to the naked eye, if any eyes had existed to see. Theia, once a perfect sphere, was now stretched into an egg shape. Her longest axis pointed directly at Earth, pulled by the differential gravity. The side facing Earth bulged outward by kilometers, while the opposite side also bulged, though less dramatically. Around her equator, the crust cracked and split, as the planet tried to accommodate its new shape. I descended to Theia's surface to experience these final hours from the world that would soon cease to exist. Standing, though nothing could truly stand in such conditions. On the Earth-facing hemisphere, the view was beyond description. Earth didn't just fill the sky. It was the sky, From horizon to horizon, the massive planet loomed, its surface a roiling ocean of lava that glowed with every shade of red and orange. The ground beneath me, beneath my imagined feet, was in constant motion. Not the sharp jolts of earthquakes, but a slow, grinding deformation as the entire hemisphere tried to fall toward Earth. Cracks opened and closed rhythmically with Theia's rotation, breathing like the planet itself was alive and struggling. Lava welled up from these cracks, not in violent eruptions, but in slow, steady flows that painted the surface with fresh rock. The soundscape on Theia's surface was unlike anything I had experienced before or since. There was the constant groan of rock under stress, a sound so low it was felt rather than heard. Overlaying this was the whistle and howl of escaping atmosphere, as gases found any crack or fissure to flee the dying world. And threading through it all was a rhythmic creaking, almost like a heartbeat, as the planet flexed with each rotation. But perhaps most remarkable was what I could feel through the rock itself. Standing on Theia's surface, I could sense Earth's gravity not as a distant force, but as an immediate, visceral pull. It wasn't uniform but varied depending on position. On the Earth-facing side, the pull was strongest, trying to lift me off Theia's surface. On the opposite side, it was weaker but still present, a constant reminder of the massive world nearby. The atmosphere was escaping in real time. I watched as gases streamed away from Theia in great spirals, following magnetic field lines and gravitational gradients. The escaping atmosphere glowed with ionization, creating a tail like a comet's but pointing toward Earth rather than away from the sun. Some of this gas would fall to Earth, adding to its atmosphere. Some would be lost to space forever, but much would remain in the Earth-Theia system, eventually to be incorporated into the Moon. As the final hours ticked by, the deformation became more extreme. Mountain ranges that had existed for millions of years crumbled like sandcastles, valleys filled with flowing rock. The very concept of solid ground became meaningless as the entire planet began to behave more like a very viscous liquid than a solid world. Let me paint for you the scene in those final hours. Earth's surface had become a hellscape beyond imagination. The tidal bulge raised by Theia's approach was now a mountain of molten rock hundreds of miles high, racing around the planet, following Theia's orbital motion. Where this bulge passed, the surface cracked open in chasms that reached down to the mantle. Lava fountained into the sky in jets that reached the upper atmosphere. The atmosphere itself was in chaos. Winds of unimaginable velocity raced around the planet, driven by the temperature differences between the heated bulge and the relatively cooler regions away from Theia's influence. These winds carried with them droplets of molten rock, creating a rain of fire that fell continuously. And the sound. Oh, the sound was beyond description. The groaning of tortured rock, the screaming of supersonic winds, the explosive roar of volcanic eruptions, all combined into a symphony of planetary transformation. Low-frequency waves traveled through the planet's interior, making the entire world ring like a struck bell. From space, the view was simultaneously beautiful and terrifying. The two worlds were now so close that material was actively transferring between them. Streams of gas and even molten rock arced between the planets, creating a bridge of fire. They were no longer two separate worlds, but a binary system in the process of catastrophic merger. I remember positioning myself at one of the Lagrange points, those special locations where the gravitational forces of the two bodies balance perfectly. From there, I could watch the dance in its full glory. Theia, distorted now into an egg shape by Earth's gravity, glowing red with internal heat. Earth, its surface a roiling sea of magma, reaching out toward its cosmic partner. In those final moments before impact, time seemed to slow. Every detail burned itself into my memory. The exact color of Theia's last sunset, a deep purple red through her dissipating atmosphere. The pattern of cracks spreading across her surface like a spiderweb of fire. The way Earth's atmosphere glowed where it was compressed by Theia's approach. And then, in the space between one heartbeat and the next, the cosmic dancers finally touched. The first contact was almost gentle, a kiss between titans. But let me take you deeper into this moment, for it deserves our full attention. Imagine yourself as a consciousness, able to experience matter at every scale, from the cosmic to the subatomic. Position yourself at the exact point where Theia first touched Earth's atmosphere. And let's experience this collision not as distant observers, but as witnesses embedded within the event itself. In the nanoseconds before contact, the space between the two worlds was still technically vacuum, but it was far from empty. Both planets leaked, Earth's atmosphere extending in wisps far beyond what we might consider its boundary. Theia trailing a comet-like tail of gas, stripped away by Earth's gravity. These tenuous gases met first, individual molecules colliding at speeds that turned them into tiny explosions of light. I watched these first molecular collisions with fascination. A nitrogen molecule from Earth meeting a methane molecule from Theia. The impact energy was so great that the molecules didn't just break apart. They disintegrated into their component atoms, and those atoms lost their electrons, becoming ions. Each collision released a tiny flash of light, and there were trillions upon trillions of them happening every second. As Theia pressed deeper into Earth's atmospheric envelope, the density of these collisions increased exponentially. What had been individual flashes became a continuous glow. The temperature at the interface rose from the cold of space to hundreds, then thousands, then tens of thousands of degrees in mere milliseconds. Let me describe the sensory experience of being within this growing maelstrom. The light was beyond blinding. Every frequency of electromagnetic radiation was being produced simultaneously. Radio waves from the movement of charged particles, infrared from the heat, visible light in every color, though dominated by the blue-white of extremely hot plasma, ultraviolet stripping electrons from any atom it touched, X-rays from the deceleration of charged particles, even gamma rays from nuclear reactions triggered by the extreme conditions. The sound, though sound is not quite the right word for pressure waves of such magnitude, was a physical force. In the thickening medium between the worlds, acoustic waves propagated, but they were so intense they were more like solid walls of pressure than anything we would recognize as sound. These waves collided, reinforced each other, created standing patterns of compression and rarefaction that lasted microseconds before being overwhelmed by new waves. And then there were sensations that have no earthly analog. The gravitational gradient was so steep that tidal forces could be felt across distances of meters. Space itself was being stressed, twisted by the massive accelerations involved. Magnetic fields, generated by the movement of charged particles, grew from nothing to strengths that would have torn apart any ordinary matter. As Theia's solid surface approached Earth's upper atmosphere, a bull shock formed. This wasn't like the bow wave of a boat through water, but rather a discontinuity in the very nature of matter. On one side, relatively normal gas, heated and compressed, but still recognizable as atmospheric components. On the other side, a state of matter that exists nowhere else in nature. a plasma so hot and dense that the distinction between matter and energy began to blur. Theia's leading edge, moving at 4 kilometers per second, touched Earth's atmosphere. For a fraction of a second, it was just compression. Gas heating, glowing, pushing aside. The air between the worlds became plasma, glowing brighter than the sun. I want you to experience this moment as I experienced it, not as a distant observer, but as a consciousness present at the point of contact. Imagine yourself there, at the boundary between two worlds, witnessing the exact instant when they ceased to be separate and began their violent transformation into something new. The air temperature at the contact point rose to millions of degrees in microseconds. Atoms dissociated into ions, electrons stripped away by the incredible energies involved. A shockwave formed, racing outward through both atmospheres at speeds that dwarfed sound itself. This was not mere wind, but a wall of star stuff, compressed to densities greater than lead, heated to temperatures found in stellar cores. Behind the shockwave, matter entered states that exist nowhere else in the solar system. Not solid, not liquid, not gas, but a fourth state. A plasma so energetic that the very concept of chemistry broke down. Atoms could not exist here. Molecules were impossibilities. There was only a soup of fundamental particles, colliding and recombining in combinations that lasted nanoseconds before being torn apart again. The light from this contact point was extraordinary. Not just visible light, though that alone would have been blinding from anywhere in the inner solar system. The collision produced radiation across the entire electromagnetic spectrum, radio waves that would echo through space for millennia, infrared that carried away the heat of worlds dying, ultraviolet and X-rays that ionized gas clouds throughout the Earth-Moon system, even gamma rays, signature of nuclear reactions triggered by the incredible pressures. As Theia's bulk pressed deeper into Earth's atmosphere, the contact area expanded. What had begun as a point became a circle, then an expanding ring of fire racing outward at hypersonic speeds. The atmosphere couldn't move aside fast enough. It was compressed, heated, and accelerated to escape velocity, fountaining into space in great jets that would be visible from Mars. I positioned myself within one of these jets, riding the escaping atmosphere into space. The experience was beyond words. A river of star-hot gas, carrying with it the vaporized remains of both worlds' outer layers. Droplets of molten rock, some as large as houses, tumbled past in the flow. Crystals of exotic minerals formed in the instant of compression and just as quickly vaporizing again, sparkled like dying stars. The sound carried even through the escaping atmosphere. Not sound as we understand it, for this was beyond the realm of ordinary acoustic waves. These were compression waves of such intensity that they bordered on becoming shock waves themselves. They rippled through the escaping gas, creating patterns of density that glowed with their own light. Then solid met solid. The crust of Theia, already molten from tidal heating, touched the crust of Earth. For a moment, they resisted each other, rock pushing against rock. But at these velocities, at these energies, even rock behaves like a liquid. Let me slow this moment down for you. Stretch it out so you can appreciate the physics of worlds colliding. When we think of solid objects colliding in our everyday experience, they might deform, crack, or shatter. But at planetary scales and cosmic velocities, matter behaves in ways that defy intuition. The rock at the contact point didn't crack. It flowed. The pressure was so intense that the crystalline structure of minerals simply ceased to exist. Silicates that had been solid for millions of years became a supercritical fluid, neither truly liquid nor gas, but something in between. This fluid rock sprayed outward from the impact point in sheets and jets. Some of it accelerated to speeds that would carry it beyond Earth's gravity altogether. I watched as the impact zone expanded. In the first second, it grew from a point to a circle hundreds of miles across. The energy released was phenomenal, more than all the earthquakes in Earth's modern history combined, released every fraction of a second. The ground didn't just shake, it rippled like water, waves of solid rock racing outward from the impact. Let me take you down to the surface level to experience these waves as they propagated. Imagine standing, though nothing could actually stand in such conditions, on Earth's crust 1,000 kilometers from the impact site. The ground beneath you is solid rock, granite and basalt that has existed for millions of years. The first indication of the catastrophe comes not through the ground, but through the planet itself. The gravitational wave from the sudden redistribution of mass arrives at the speed of light, a ripple in space-time that momentarily changes the very nature of up and down. Sensitive instruments would detect this as a minute change in gravitational acceleration. But at the magnitudes involved here, you would feel it in your bones, if you had bones. Then comes the electromagnetic pulse. The collision has created a burst of charged particles and radiation that races outward at light speed. The sky lights up with an auroral display that covers the entire hemisphere, sheets of green and red and colors that have no names because they come from transitions in ions that don't exist under normal conditions. The seismic waves arrive minutes later, but their approach is heralded by a sound unlike anything in terrestrial experience. The planet itself is ringing, vibrating at frequencies so low, they bypass the ears and are felt directly through the body. This isn't the sharp crack of breaking rock or the rumble of an earthquake, but a deep, sustained note that seems to come from everywhere at once. Then the ground begins to move, not the sharp jolting of a normal earthquake, but a smooth, almost liquid motion. The solid rock beneath behaves like a heavy fluid, rising and falling in waves dozens of meters high. The granite flows, not melting but deforming plastically under stresses that exceed its strength by orders of magnitude. I watched as mountains were unmade by these waves. Peaks that had stood for millions of years crumbled like sandcastles. Valleys filled with flowing rock. The very concept of solid ground became meaningless as the planet's surface behaved more like an ocean than land. But this was just the beginning. Behind the seismic waves came the atmospheric shock. The air itself, compressed to densities greater than water and heated to stellar temperatures, arrived as a glowing wall racing across the landscape. Everything it touched was not just vaporized but dissociated into component atoms. Those atoms ionized into plasma. That plasma swept up and carried along in the expanding wavefront. From my vantage point within this chaos, I could observe phenomena that existed for fractions of seconds before being destroyed. Crystals of minerals formed under impossible pressures, their atomic structures compressed into configurations that defied normal chemistry. These existed for nanoseconds before the temperature dissolved them back into their component atoms. Lightning played continuously through the expanding cloud. But this wasn't ordinary lightning. The potential differences were so extreme that the discharges created channels of matter in states that don't have names. Plasma so energetic that nuclear fusion occurred along the lightning paths, creating new elements in the fierce electric crucibles. These weren't ordinary seismic waves. They were shock waves traveling through solid matter, compressing rock to densities greater than metal. Behind the shock front, the rock was so hot it glowed white, then blue-white, temperatures that turned granite to vapor and metal to plasma. As Theia pushed deeper into Earth, something extraordinary happened. The angle of impact, that precise 45-degree approach that gravity and momentum had choreographed, meant that Theia wasn't simply crashing down onto Earth. She was sideswiping it, delivering a glancing blow that would have profound consequences. The impact was peeling Earth's surface like an orange. Layers of crust and upper mantle were being scraped away, lifted into space by the tremendous tangential velocity. This wasn't destruction. It was cosmic sculpture, two worlds reshaping each other through their violent embrace. I moved my consciousness to Earth's opposite side to witness the arrival of the shock waves. They had traveled through the planet's interior, losing some energy, but still carrying force beyond imagination. When they converged at the antipode, the interference patterns created a scene of chaotic beauty. The surface erupted in fountains of lava that reached into space. The crust cracked in perfect radial patterns, like a window struck by a stone, but on a planetary scale. Meanwhile, at the impact site itself, Theia continued her inexorable merger with Earth. Her leading edge had now penetrated hundreds of miles into Earth's body. The two worlds were no longer separate entities, but a single, chaotic system. Material from both planets mixed in ways that would have profound implications for the world to come. The energy release was beyond comprehension. In seconds, more energy was liberated than the sun produces in an hour. The impact point became a fountain of vaporized rock, jetting into space at speeds exceeding solar escape velocity. Let me help you truly grasp the scale of these energies by breaking them down into more relatable comparisons, though even these will strain belief. The kinetic energy of Theia at impact was approximately 10 to the 29th power joules. To put this in perspective, this is enough energy to power our entire modern civilization at current consumption rates for 10 billion years, melt the entire Earth's crust down to the mantle, accelerate the moon to escape velocity from the solar system 1,000 times over, create a crater on Earth visible from the outer planets with the naked eye. But these are just numbers. Let me show you what this energy looked like, felt like, sounded like as it was released. At the impact site, the energy density was so extreme that matter entered states that normally exist only in the cores of stars or in the first microseconds after the Big Bang. The pressure exceeded a terapascal, 1 trillion times atmospheric pressure. The temperature reached millions of degrees, hot enough to ionize not just atoms, but to begin breaking apart atomic nuclei themselves. I witnessed the creation of a plasma jet that would have been visible from across the solar system. This wasn't a simple fountain of material, but a complex, magnetically confined stream of charged particles and vaporized rock. The jet had structure, a dense core where the material was so hot, it emitted X-rays surrounded by cooler, though still incandescent, layers that glowed in visible light. The magnetic fields generated by this moving charged material were extraordinary. They reached strengths of thousands of Gauss, strong enough to levitate iron at distances of kilometers. These fields channeled the flow of material, creating helical patterns as charged particles spiraled along field lines. Lightning of unprecedented power crackled through the jet, each bolt carrying more energy than all the thunderstorms on modern Earth combined. The sound of this energy release defies description. In the dense plasma of the impact site, sound waves propagated at velocities approaching a significant fraction of the speed of light. The frequencies were so high that they bordered on becoming electromagnetic radiation. These hypersonic acoustic waves created their own shock fronts, heating material through compression alone. But the energy wasn't released only as heat and motion. A significant fraction went into changing the state of matter itself. I watched as ordinary silicate minerals were dissociated into their component atoms, then ionized into bare nuclei and electrons. Some of the energy went into creating new isotopes through nuclear reactions. Carbon became nitrogen, oxygen became fluorine, silicon transmuted into phosphorus. The impact had become an alchemist's forge, creating new elements from old. The electromagnetic pulse from the impact was itself a weapon of planetary destruction. Racing outward at the speed of light, it carried enough energy to ionize gas at distances of millions of kilometers. Any hypothetical satellites orbiting Earth would have been destroyed instantly, their electronics fried and their structures heated to incandescence by induced currents. The pulse would have been detectable by any hypothetical civilizations in nearby star systems, a brief flash announcing that something extraordinary had happened in the young solar system. To understand the scale of energy we're discussing, let me give you a comparison. Every nuclear weapon ever built by humanity, detonated simultaneously, would be a firecracker compared to this. The impact released energy equivalent to billions of nuclear explosions every second, for hours. This energy had to go somewhere, and it went everywhere. Some of it became heat, raising temperatures across both planets to levels that vaporized rock and metal alike. Some became kinetic energy, accelerating vast masses of material to cosmic velocities. Some became pressure waves, traveling through both worlds and tearing them apart from within. But perhaps most remarkably, some of this energy went into creating new forms of matter. In the heart of the impact, pressures exceeded those at Earth's center. Temperatures rivaled the surface of the sun. In these conditions, ordinary matter was transformed. New mineral phases formed, crystals that could exist nowhere else. Metals and silicates combined in ways impossible under normal conditions. I witnessed the birth of minerals that would later be found as microscopic inclusions in moon rocks, tiny time capsules preserving the conditions of this cosmic forge. Stishovite, a form of quartz so compressed it approached the density of metal. Ringwoodite and wadsleyite, high-pressure forms of olivine that normally exist only in planetary depths. These minerals formed, existed for seconds or minutes, then were either preserved or transformed again as conditions changed. The fountain of material ejected from the impact site was a wonder to behold. It wasn't a single jet, but countless individual streams, each following its own trajectory. Some material was launched straight up, rising on perfectly vertical paths until gravity slowly turned it back. Other streams followed graceful arcs, parabolas and ellipses painted in glowing rock across the sky. The fastest moving material exceeded solar escape velocity. These fragments, torn from both Earth and Theia, would leave not just Earth's gravity but the solar system entirely. Somewhere in interstellar space, pieces of the young Earth and the world that struck it still drift, carrying their story to the stars. But most of the ejected material remained bound to Earth, though it would take various paths before finding its final destination. Some fell back immediately, raining down as a hellish bombardment that added to the chaos. Some entered complex orbits, circling the Earth in rings and streams that would persist for centuries. And some would begin the long, slow process of gathering together to form our moon. As Theia carved deeper into Earth, the scale of destruction grew beyond planetary. This was no longer just two worlds colliding. It was the birth of a new order through chaos. The word splash might evoke images of a stone dropping into a pond, but this was Splash reimagined on a scale that challenges comprehension. Imagine, if you will, an ocean made not of water, but of liquid rock, and into this ocean falls not a stone, but an entire world. The physics are the same: displacement, fluid dynamics, wave propagation. But the scale transforms these familiar concepts into something altogether alien. As Theia's bulk penetrated Earth's surface, it displaced a volume of material equal to a significant fraction of Earth itself. This material had nowhere to go but up and out. The ejection wasn't uniform but focused by the angle of impact into a preferred direction, creating a vast plume of material that rose from the impact site like a cosmic geyser. I want you to experience this from within the ejected material itself. Imagine you are a cube of granite, a meter on each side, that moments ago was buried kilometers beneath Earth's surface. You've existed in the same location for billions of years, compressed by the weight of rock above, heated by radioactive decay and the planet's internal heat, but essentially unchanged since Earth's formation. Suddenly, the world explodes around you. The pressure that has held you in place for eons vanishes in an instant. The rock above you isn't just removed, it's accelerated away at speeds that exceed escape velocity. You find yourself surrounded by a matrix of material that's no longer solid, no longer liquid, but something in between. A supercritical fluid, where the distinctions between phases of matter cease to have meaning. The acceleration is beyond anything material objects are designed to withstand. In less than a second, you go from motionless to traveling at kilometers per second. The G-forces involved would crush any conceivable structure. But at these energies, the very concept of structural integrity becomes meaningless. You're not a solid cube anymore, but a droplet of molten rock, shaped by the competing forces of acceleration and surface tension. Around you, the ejected material forms a complex, three-dimensional flow pattern. Rivers of molten iron from Earth's core flow alongside streams of lighter silicates from the crust. Material from Theia mixes with Earth material in proportions that vary, depending on location within the plume. Some regions are dominated by one or the other, while in other areas the mixing is so complete that the distinction becomes meaningless. The temperature varies dramatically within the plume. Near the impact point, where compression heating and kinetic energy conversion are most extreme, temperatures exceed 10,000 Kelvin. Here, rock doesn't just melt, it boils. Droplets of liquid rock flash to vapor, creating expanding bubbles within the flow. These bubbles rise through the denser liquid, creating a frothy, churning mixture that resembles nothing so much as cosmic champagne. As you rise with the plume, carried upward by forces beyond comprehension, the environment around you changes rapidly. The pressure drops exponentially, allowing dissolved gases to come out of solution. The liquid rock effervesces, releasing volatiles that had been locked in the planetary interior for billions of years. Water vapor, carbon dioxide, sulfur compounds. All contribute to the expanding gas phase that helps accelerate the material to even greater heights. The splash is perhaps too gentle a word for what occurred, yet it captures something essential about the fluid nature of this cosmic event. When a stone falls into water, it creates a crown-shaped splash, droplets flying outward in perfect radial symmetry. Now imagine that on a planetary scale, with molten rock instead of water, and energies that defy comprehension. As Theia's bulk pressed into Earth, it displaced vast volumes of material. But unlike water, which flows back to fill the void, This displaced rock was accelerated to escape velocity. It fountained into space in great sheets and spirals, some of it glowing so brightly it outshone the sun itself. I positioned myself within this maelstrom, experiencing it from every angle. From above, the impact site resembled a vast caldera, kilometers deep and hundreds of kilometers across. But this caldera was dynamic, expanding every second as more of Theia merged with Earth. The walls weren't solid but flowing, rivers of molten rock racing upward and outward. The colors within this splash were extraordinary. The hottest material glowed blue-white, temperatures exceeding 6,000 degrees. As it expanded and cooled, it passed through every color of the spectrum. White to yellow, yellow to orange, orange to red. Some droplets cooled enough to solidify in flight, becoming glassy spheres that caught and reflected the light of the chaos around them. But this wasn't just a splash of liquid. The impact had vaporized vast quantities of rock, creating an atmosphere of rock vapor that expanded outward faster than the liquid debris. This vapor glowed with its own light, a plasma of silicon, oxygen, iron, and a dozen other elements. As it expanded and cooled, it began to condense, first into tiny droplets, then into a fine dust that sparkled like diamond powder. Within the expanding cloud of debris, chemistry was happening at a pace normally associated with biological systems. Atoms and molecules combined and recombined millions of times per second. Silicon and oxygen formed chains and rings. Iron and nickel created metallic droplets. More exotic combinations appeared and disappeared in the chemical chaos. I watched as the first solid particles began to form within the vapor. They started as microscopic crystals, nucleating around random impurities or simply from the supersaturation of the cooling gas. These grew rapidly, some remaining as individual crystals, others clumping together into the first aggregate particles. The impact had effectively turned both worlds inside out. Material from deep within Earth's mantle was now flying through space. Theia's core, that dense heart of iron and nickel, was merging with Earth's own center. Let me take you deep inside the chaos, to the very point where Theia's core met Earth's. This was not a gentle merger, but a violent injection of one world's heart into another. Theia's core, a sphere of iron and nickel the size of Mars's core, punched through Earth's mantle like a cosmic bullet. The densities involved were staggering. Iron at these pressures doesn't behave like the metal we know. It becomes a superdense fluid, its atoms packed so tightly that electrons are forced into configurations that don't exist under normal conditions. When Theia's core met Earth's core, it wasn't like two drops of liquid mercury combining. It was a collision between two states of matter pushed to their extreme limits. The pressure waves from this deep merger raced outward through both planets. They moved faster than sound, faster than any seismic wave measured in Earth's modern age. These waves carried with them the signature of the merger, changes in density, temperature, and composition that would fundamentally alter Earth's internal structure. Meanwhile, at the surface, the splash continued to evolve. The initial radial symmetry was breaking down, influenced by the angle of impact and the rotation of both worlds. The debris wasn't spreading uniformly, but was concentrated in a great arc that wrapped around Earth. From space, it resembled a cosmic spiral arm, a galaxy of molten rock with Earth at its center. Within this spiral, I observed the birth of the first moonlets. Not our moon. Not yet. But smaller bodies that formed from the immediate condensation of debris. These range from mountain-sized chunks of solid rock to smaller aggregates of dust and vapor. Each had its own orbit, its own destiny, Some would fall back to Earth within hours or days. Others would collide with each other, growing larger or shattering apart. And some would begin the slow process of sweeping up smaller debris, clearing their orbital paths. The temperature gradients within the debris cloud created their own weather systems. Hot material rising, cooler material falling, creating convection cells that span thousands of kilometers. These cells transported not just heat, but material, mixing debris from Earth and Theia in proportions that would later be preserved in lunar samples. I remember following one particular stream of debris, tracking it from its origin deep in Earth's mantle to its eventual fate. It began as solid rock, heated beyond its melting point by the impact. The shock acceleration turned it into a droplet of magma, then further heating transformed it to vapor. It rode the expanding shock wave into space, cooling as it went, condensing first to liquid, then solidifying into a glassy bead. This bead didn't travel alone. It was part of a stream containing billions of similar particles, all following nearly identical trajectories. Together, they formed a river of glass flowing through space, catching the sunlight and sparkling like a celestial waterfall. Eventually, this stream would intersect with a growing moonlet, adding its mass to what would eventually become part of our moon. As I watched this cosmic splash evolve, I was struck by the sheer scale of transformation. Two worlds, each with their own 4 billion-year history, were being unmade and remade in a matter of hours. Every atom was being given a new destiny. Some would remain with Earth, eventually becoming part of continents and oceans. Others would join the moon, to be walked upon by astronauts billions of years hence. Still others would escape entirely, carrying their elemental cargo to the outer solar system or beyond. The debris disk that formed around Earth was not uniform, but had structure from the very beginning. The angle of impact meant that most material was ejected in a preferred direction, creating a disk that was thicker on one side. Theia's velocity had been added to the ejected material, giving it angular momentum that would eventually manifest as the moon's orbital motion. Within hours, the disk had spread to encompass a volume larger than Earth itself. The inner edge, where material was too hot or moving too fast to condense, formed a glowing torus. Further out, where conditions allowed solid particles to survive, distinct rings began to form, separated by gaps where orbital resonances made stable orbits impossible. I spent time in each of these regions, experiencing the different conditions. In the inner torus, temperatures exceeded 3,000 degrees. Everything was plasma or vapor. The density was high enough that collisions between particles happened continuously, creating a kind of fluid behavior despite the lack of true liquid. In the middle regions, where the first solid particles were condensing, the environment was more varied. Pockets of hot gas alternated with regions where solid particles dominated. Lightning crackled between differently charged regions, adding another layer of energy to the already chaotic scene. The outer regions were cooler but no less dynamic. Here, larger solid chunks that had survived the initial impact intact tumbled through space. Some were fragments of Theia's crust, preserving the mineralogy of a world now destroyed. Others were pieces of Earth's mantle, ripped away and flung into orbit. These would become the seeds around which smaller particles would accrete. Hours passed. The debris cloud expanded, cooled, began to organize itself under the inexorable influence of gravity. But let us not rush through these hours, for each one contained drama and transformation on a scale that defies imagination. The first hour after impact was perhaps the most chaotic period in Earth's entire history. The planet was no longer a sphere, but an oblate, deformed mass, its shape distorted by the violence of the collision and the massive redistribution of material. I positioned myself at various points around the Earth system during this first hour, experiencing the event from every possible perspective. From the sunward side, the view was dominated by the glowing plume of ejected material, a fountain of liquid light that rose higher than the diameter of Earth itself. The sun's light, filtered through this column of vaporized rock, took on colors that no sunset has ever displayed. Deep purples from ionized iron, electric blues from silicon plasma, greens from vaporized olivine. From Earth's night side, the spectacle was even more dramatic. The entire horizon glowed with the light of the impact, bright enough to read by even on the opposite side of the planet. But this wasn't the steady glow of ordinary light. It flickered and pulsed as shock waves propagated through the atmosphere, compressing and heating the air in waves that circled the globe. The sound of this first hour was a symphony of destruction. The initial impact had created acoustic waves of such intensity that they didn't just travel through the air. They traveled through everything. The entire planet rang like a bell, vibrating at multiple frequencies simultaneously. The fundamental mode, with a period of about 20 minutes, caused the entire planet to expand and contract rhythmically. Higher harmonics created more complex patterns, with some regions of the surface rising while others fell. In the space around Earth, the environment was equally chaotic. The fastest moving ejector had already traveled thousands of kilometers from the planet, but it wasn't traveling through empty space. Earth's magnetosphere, that invisible shield that protects us from solar radiation, had been severely disrupted by the impact. The sudden injection of charged particles created electric currents of unimaginable intensity, which in turn generated new magnetic fields that twisted and tangled with the existing ones. I watched as these magnetic field lines, made visible by the streams of charged particles flowing along them, created a web of light around the planet. Auroras, not just at the poles but everywhere, sheets of colored light that danced and swirled as the magnetic field reconfigured itself. Lightning jumped between regions of different electrical potential, creating bolts that stretched for thousands of kilometers through the near-Earth environment. Meanwhile, on what remained of Earth's surface, the landscape was being remade on a scale that defied comprehension. The impact had created a crater, though crater seems too small a word for a depression that spanned a significant fraction of the planet's surface. The edges of this depression were not stable cliffs, but flowing waterfalls of molten rock, constantly collapsing and reforming as materials sought gravitational equilibrium. The heat generated by the impact had created convection patterns of unprecedented scale. Plumes of superheated material rose from the impact site, cooled as they reached higher altitudes, then sank again, creating circulation cells that spanned continents. These convection cells didn't just move heat, they moved material, mixing the planet's interior in ways that would have taken billions of years of normal geological activity. Some material fell back to Earth immediately, a rain of fire that lasted for days. But much remained in orbit, beginning its transformation. The hours immediately following the impact were a time of constant change. Every second brought new configurations, new possibilities. Let me walk you through this critical period, when the fate of the Earth-Moon system hung in the balance. In the first hour, the debris cloud was still dominated by vapor and liquid droplets. The temperature, even hundreds of kilometers from Earth, exceeded 2,000 degrees. Any solid particles that formed were quickly re-vaporized by collisions or thermal radiation. The cloud glowed like a diffuse star, its light casting strange shadows on Earth's ravaged surface below. By the second hour, the outer edges of the cloud had cooled enough for permanent condensation to begin. Tiny crystals of olivine and pyroxene, the building blocks of rocky worlds, began to form. These crystals were perfect, their atomic structure unconstrained by the defects and impurities that mark minerals formed under less extreme conditions. The third hour saw the first significant accumulations. Crystals stuck together when they collided, held by electrostatic forces and microgravity. These aggregates were fragile gossamer structures that would shatter at the slightest disturbance. But in the relative calm of their orbital paths, some survived and grew. I spent these hours moving through the debris cloud, witnessing phenomena that existed nowhere else in the solar system. Lightning played between charged particles, creating a constant flickering illumination. Magnetic fields, generated by the movement of ionized gas, created invisible channels that guided the flow of charged particles into streams and sheets. By the sixth hour, distinct structures were emerging within the cloud. The material wasn't distributed uniformly, but was concentrating into bands and rings. The innermost material, too hot and energetic to condense, formed a glowing torus around Earth. Further out, where temperatures allowed solid particles to survive, a series of discrete rings began to form. These rings were dynamic structures. Material constantly transferred between them through collisions and gravitational perturbations. Particles in lower orbits moved faster, catching up with and accreting material from higher orbits. This process, known as shepherding, began to clear gaps in the disk and concentrate material into specific zones. The rain of fire falling back to Earth was its own spectacle. Unlike meteor showers, which come from specific directions, this bombardment came from everywhere. The entire sky glowed with returning debris. Some pieces were small, burning up completely in Earth's atmosphere and adding to its mass. Others were substantial, impacting with enough force to create secondary debris plumes. Earth's surface during this bombardment defied description. Already molten from the initial impact, it was now being constantly refreshed by new impacts. The surface literally boiled, with bubbles of vapor rising through the magma ocean and bursting in sprays of lava. There was no solid ground anywhere on the planet, just an endless expanse of glowing, churning rock. In the days and weeks that followed, I witnessed one of the cosmos's most elegant dances, the slow gathering of scattered pieces into a new world. But before we watch this gathering, let me paint for you the scene in those first days. The space around Earth had been transformed from the empty vacuum of the inner solar system into a dense, dynamic environment. The debris from the impact wasn't uniformly distributed, but formed a vast, asymmetric disk that extended from just above Earth's atmosphere to beyond the distance where our moon now orbits. This disk had structure from its very first moments. The angle of impact and the rotation of both bodies had imparted angular momentum to the ejected material, causing it to orbit Earth, rather than simply falling back or escaping to interplanetary space. But within this overall rotation, there were currents and eddies, streams of material moving at different speeds and in different directions. I spent days exploring this disk, marveling at its complexity. Near Earth, where the material was densest and hottest, it resembled a glowing fog. Droplets of liquid rock, ranging from microscopic to meters across, filled space so densely that visibility was limited to kilometers. The constant collisions between these droplets created a continuous sparkle of light, like fireflies in a summer evening, but with each flash representing the violent merger of molten rock. The temperature gradient within the disk was extreme. Near Earth, where fresh material was still being added by secondary impacts and volcanic eruptions triggered by the collision, temperatures exceeded 3000 Kelvin. Moving outward, the temperature dropped rapidly, following a power law that reflected the balance between radiative cooling and heating from collisions. At a certain distance from Earth, roughly where the Moon's orbit would eventually be established, something remarkable happened. The temperature dropped below the condensation point of rock vapor, and for the first time since the impact, solid particles began to form that could survive. These weren't large particles. Most were smaller than sand grains, but they were solid, and they were persistent. I watched the birth of these first permanent particles with the same wonder a parent might feel watching a child take first steps. Each particle began as a cluster of atoms, perhaps silicon and oxygen coming together to form the beginning of a silicate crystal. In the supersaturated vapor, these clusters grew rapidly, adding layer after layer of atoms in perfect crystalline arrangement. The shapes of these early crystals were exquisite. Free from the constraints of gravity or surrounding rock, they grew in their ideal forms. Perfect octahedrons of magnetite, needles of pyroxene, complex forms of olivine that revealed the underlying mathematics of crystal structure. Each was a tiny work of art, a manifestation of the order that emerges naturally from chaos when conditions are right. But these particles didn't remain isolated for long. The disk was dense enough that collisions were frequent, and when two particles met at low relative velocities, they tended to stick together. The mechanism was primarily electrostatic. The particles carried charges acquired during their formation, and opposite charges attracted, holding the particles together despite the weak gravity. I followed one particular aggregate as it grew from 2 particles to 4, then 8, then hundreds. Each collision added mass, but also complexity. The aggregate wasn't a solid mass, but a fluffy, fractal structure with more empty space than solid material. It rotated slowly, its irregular shape causing it to tumble in complex patterns as it orbited Earth. These early aggregates were fragile. A collision at too high a velocity would shatter them, sending their component particles flying apart to begin the aggregation process anew. But statistically, more collisions were constructive than destructive, and the overall trend was toward growth. Within the disk, different regions evolved at different rates. Where the density was highest, typically in the plane of Earth's equator, and at intermediate distances from the planet, growth was fastest. Particles collided frequently, and the relative velocities were low enough that most collisions resulted in sticking rather than fragmentation. In other regions, particularly close to Earth where tidal forces were strong, or far from Earth where the density was low, growth was slower or even negative. These regions acted as reservoirs, storing material that would later be swept up by the growing bodies in more favorable locations. The physics governing this growth was fascinating. Each particle, no matter how small, orbited Earth according to Kepler's laws. Those closer to Earth orbited faster, those farther away slower. This meant that particles in adjacent orbits slowly drifted past each other, providing opportunities for collision and growth. But the orbits weren't static. Collisions changed orbital parameters, sometimes dramatically. A particle moving in a circular orbit might collide with one in an eccentric orbit, resulting in 2 particles with intermediate characteristics. Over time, This process, called dynamical relaxation, caused the disk to evolve toward a more uniform, circular configuration. Gravitational perturbations added another layer of complexity. Earth wasn't a perfect sphere. The impact had deformed it, creating a lumpy gravitational field that changed as the planet gradually returned to hydrostatic equilibrium. These changing gravitational perturbations stirred the disk, preventing it from settling into a completely stable configuration and ensuring continued mixing and collision opportunities. The process began almost immediately, though its end would not come for centuries. In those first days, the debris disk around Earth was a chaotic place. Millions, perhaps billions of individual particles, ranging from microscopic dust grains to chunks the size of mountains, all orbiting in slightly different paths, at slightly different speeds. Let me take you into this disk to experience what it was like to drift among the building blocks of our future moon. The space around Earth was no longer empty, but filled with a glowing haze. Everywhere you looked, particles drifted past. Some moved in stately procession, following nearly circular orbits. Others raced by on highly elliptical paths, diving close to Earth before swinging back out to the edge of the disk. The collisions were constant. In the densest parts of the disk, particles couldn't travel more than a few meters without encountering another. Most of these collisions were gentle, relative velocities of just meters per second. When two particles met at these speeds, they tended to stick together, held by the weak forces of gravity and electrostatics. I watched countless such collisions, each one a tiny step in the moon's construction. A dust grain meeting another dust grain, creating a slightly larger particle. That particle encountering a small pebble, growing larger still. It was accretion in its purest form, growth by gradual accumulation. But not all collisions were constructive. When relative velocities exceeded a critical threshold, impacts became destructive. I witnessed moonlets the size of cities shatter when they collided too forcefully, creating new clouds of smaller debris that would have to begin the accretion process anew. It was a balance between creation and destruction, with gravity slowly tipping the scales toward growth. Within days, the first substantial bodies began to emerge. These proto-moonlets, ranging from kilometers to tens of kilometers across, became gravitational anchors within the disk. Their gravity, while weak, was enough to begin clearing their orbital neighborhoods, sweeping up smaller debris like cosmic vacuum cleaners. I chose one of these early moonlets to follow closely, watching as it grew from a rough aggregate of rock and dust into something more substantial. Each orbit brought new material. Sometimes it was a gentle rain of dust, adding perhaps a meter of new material across its entire surface. Other times, it was the dramatic merger with another moonlet of similar size, doubling its mass in minutes. The internal structure of these growing bodies was fascinating. The earliest aggregates were essentially rubble piles, collections of smaller pieces held together by gravity alone. But as they grew larger and accumulated more material, the pressure in their interiors began to rise. Rock that had been loosely packed began to compress, squeezing out void spaces, creating a more solid structure. The disk itself was evolving. What had started as a roughly uniform cloud was developing structure. Gravitational resonances created gaps, zones where orbits were unstable and debris couldn't linger. Other regions became concentrated as orbital dynamics shepherded material into narrow bands. These resonances were like invisible architecture within the disk, mathematical patterns made manifest in the distribution of matter. Where orbital periods formed simple ratios, 2 to 1, 3 to 2, 5 to 3. Particles couldn't maintain stable orbits. They would be pushed inward or outward, clearing gaps that resembled the rings of Saturn, but on a much grander scale. I spent weeks studying these patterns, watching as they evolved and shifted. The disk was never static, but constantly reorganizing itself. A moonlet growing larger would shift the resonances around it, opening new gaps and closing others. The merger of two large bodies could send ripples through the entire disk, triggering cascades of secondary collisions. The composition of the disk varied with distance from Earth. Close in, where temperatures remained extreme, only the most refractory materials could exist as solids. These were rich in metals and high-temperature minerals, the same materials that form the crusts of terrestrial planets. Further out, where temperatures were lower, more volatile materials could condense, including water and other compounds that had been vaporized in the impact. This compositional gradient would have profound implications for the Moon's formation. The bodies forming in different regions of the disk had different compositions, different densities, different internal structures. When they eventually merged, they would create a moon with its own complex internal layering. One of the most beautiful phenomena in the disk was the constant play of light. The sun, though dimmed by the haze of debris, still illuminated the scene. But now there were other light sources. Earth itself glowed like a coal, its surface still molten from the impact. The larger moonlets, heated by the constant rain of impacts on their surfaces, glowed with their own dull red light. And there was the light from the collisions themselves. Every impact, no matter how small, released a flash of light. In the denser parts of the disk, these flashes were constant, creating a flickering illumination like fireflies on a summer night. Larger collisions produced more dramatic displays, briefly outshining everything around them. As weeks turned to months, a hierarchy emerged within the disk. The largest bodies, those that had been lucky enough to avoid destructive collisions while accumulating mass efficiently, began to dominate their regions. Their gravity reached out further, pulling in material from ever wider zones. The rich got richer in this cosmic economy, while smaller bodies found themselves in increasingly unstable situations. I watched as the largest moonlets began their final dance. There were perhaps a dozen of them, each the size of a small moon in its own right. Their orbits brought them close to each other, and gravity began to work its inevitable magic. This final dance was a study in orbital mechanics played out on a grand scale. Each moonlet followed its own path, determined by its initial velocity and position when it formed. But these paths weren't independent. Each body's gravity influenced all the others, creating a complex web of interactions that would have challenged even modern supercomputers to fully calculate. I spent weeks mapping these orbital interactions, fascinated by their complexity. The largest moonlet, nearly 1,200 kilometers across, acted as the system's gravitational anchor. Its presence had cleared a gap in the disk around its orbit, much like Jupiter clears gaps in the asteroid belt. But unlike Jupiter's stable influence, this moonlet's gravity was actively drawing in the other bodies, slowly but inevitably. One particularly fascinating interaction involved three moonlets in a temporary resonance chain. The innermost completed exactly 3 orbits for every 2 of the middle moonlet, which in turn completed exactly 2 orbits for every one of the outermost. This resonance protected them from direct collision, but it wasn't stable. Small perturbations from other passing bodies gradually degraded the perfect mathematical relationship. I watched as this resonance slowly fell apart over the course of weeks. First, the innermost moonlet's orbit became slightly elliptical, breaking the perfect 3:2 ratio. This change propagated through the system like ripples in a pond. The middle moonlet's orbit responded by becoming eccentric as well. The outermost moonlet, no longer locked in resonance, began to drift inward. The physics of these interactions was beautiful in its mathematical precision. Each close approach between two bodies exchanged angular momentum according to strict conservation laws. A moonlet passing inside another's orbit would be accelerated, gaining energy and moving to a higher orbit. The outer moonlet would be decelerated, losing energy and dropping lower. Through countless such interactions, the system evolved toward its final configuration. But these weren't just point masses interacting through gravity. Each moonlet was a world unto itself, with its own internal structure, composition, and thermal evolution. The largest ones had differentiated, with denser materials sinking to form cores. They had their own volcanic activity, powered by the heat of accretion and radioactive decay. Some even had thin atmospheres of vaporized rock that created miniature comet-like tails as they orbited. I chose to spend time on the surface of one of these moonlets, experiencing what it was like to ride a small world as it spiraled toward its doom. The moonlet I chose was about 400 kilometers across, large enough to be roughly spherical, but small enough that its gravity was less than 1% of Earth's. Standing on its surface, I could have jumped hundreds of meters high, if jumping were possible on a world covered in molten lava. The view from this moonlet was extraordinary. The proto-moon, our destination, loomed larger with each orbit. Its glowing surface showed complex patterns of convection, with hot plumes rising from the interior, creating bright spots that slowly faded as they cooled. Other moonlets were visible as bright points of light, their positions changing noticeably over the course of hours as they pursued their own orbital paths. Earth dominated one side of the sky, still glowing from the heat of impact, but beginning to show the first signs of a solid crust. Dark patches had formed where the surface had cooled enough to solidify, only to be broken up again by convection or new impacts. The planet's rapid rotation was visible, features moving across the disk in a matter of hours. But most fascinating was watching the other moonlets and the debris disk itself. The disk had structure. Denser rings, separated by gaps, spiral arms where gravitational interactions had concentrated material, and vast sheets of fine dust that caught the sunlight like cosmic fog. Occasionally, a particularly large collision between smaller bodies would create a flash of light and an expanding cloud of new debris. Let me describe these titans of the disk, for each had its own character, its own history written in rock and metal. The largest was perhaps 1,000 kilometers across, a world in its own right, with enough gravity to pull itself into a roughly spherical shape. Its surface bore the scars of countless impacts, a cratered landscape that spoke of violent growth. Another major moonlet orbited further out, following a more elliptical path that brought it diving through the disk twice each orbit. This body had a different composition, richer in volatiles that gave it a lower density. When it passed through the denser regions of the disk, it would emerge trailing a temporary atmosphere, gases liberated by the heat of impacts. A third moonlet, smaller but denser, orbited in a perfect resonance with the largest body. For every 2 orbits of the giant, this smaller world completed exactly 3. This resonance protected it from direct collision, but it also meant that the 2 bodies exchanged angular momentum with each orbit, slowly changing their paths in a cosmic ballet that would eventually bring them together. I positioned myself at various points in the disk to watch these interactions. From Earth's surface, still molten but beginning to form a thin crust in places, the moonlets appeared as bright points of light moving against the starry background. But they weren't points. Through the hazy atmosphere, they showed visible disks, some large enough to see surface features. The interactions between these major bodies created waves in the disk. When two moonlets passed close to each other, their combined gravity would pull streamers of smaller debris into new orbits. These streamers twisted and wound through space, creating spiral patterns reminiscent of galaxies but lasting only days or weeks before being disrupted by the next encounter. One particularly dramatic event occurred when two mid-sized moonlets, each perhaps 500 kilometers across, finally collided after orbiting each other for weeks. I watched from multiple vantage points as they spiraled inward, their mutual gravity overcoming the angular momentum that had kept them apart. The collision was not head-on but oblique, the two bodies sliding past each other even as gravity pulled them together. The contact point liquefied instantly, sending sheets of molten rock spraying into space. But unlike the original Theia impact, this collision was slow enough that most material remained bound to the merging bodies. Over the course of hours, the two moonlets merged into one, their materials mixing and stratifying according to density. The heat of collision melted much of both bodies, allowing metal to sink toward the center, while lighter rock floated to the surface. A new, larger moonlet was born, inheriting angular momentum from both parents and settling into a new orbit. This process repeated across the disk. Sometimes the mergers were gentle, two bodies coming together so slowly that they simply stuck. Other times, they were catastrophic, generating new debris clouds that would take months to reaccrete. But always, inevitably, the trend was toward fewer, larger bodies. The final assembly came not with violence, but with an almost tender inevitability. The remaining large bodies had cleared most of the disk, their orbits now predictable, their eventual merger certain. But let me not rush to this conclusion without showing you the full magnificence of the moon's assembly. By this stage, several months after the impact, the debris disk had evolved from a chaotic cloud into an organized system. The largest proto-moon had grown to nearly 3,000 kilometers in diameter, a world in its own right, glowing with the heat of its violent assembly. This proto-moon was fascinating to observe. Unlike the smaller moonlets, which remained essentially rubble piles held together by weak gravity, this body had crossed a critical threshold. Its gravity was strong enough to pull it into a roughly spherical shape, and the pressure in its interior was sufficient to cause differentiation. The separation of materials by density. I spent weeks studying the interior of this growing world, using my ability to perceive matter at all scales to watch the process of differentiation unfold. In the deep interior, where pressures exceeded those at Earth's center, iron and other dense elements were slowly sinking toward the center. The process wasn't smooth but occurred in avalanches, as accumulated dense material would suddenly overcome the viscosity of the surrounding rock and plunge downward in great diaper-like flows. Above this forming core, the mantle was a seething ocean of molten silicates. Convection cells, driven by heat from below and cooling from above, created a complex pattern of circulation. Hot material rose in great plumes, spread across the upper mantle, cooled, and sank again. These convection patterns weren't stable, but constantly shifted, creating a dynamic interior that would have been fascinating to map if it hadn't been changing faster than any map could capture. The surface of the proto-moon during this period was unlike anything in our modern solar system. It wasn't solid. No rocky world of this size could maintain a solid surface with the amount of heat being generated by ongoing accretion. Instead, it was covered by a magma ocean, perhaps 100 kilometers deep, that glowed with its own light. This magma ocean wasn't uniform. Areas where recent impacts had occurred glowed white-hot, while regions that had been undisturbed for hours or days cooled to a dull red. Occasionally, a particularly large impact would create waves in the magma ocean, tsunamis of liquid rock that raced across the surface at hundreds of kilometers per hour. The remaining moonlets orbited this proto-moon like a miniature solar system. I counted perhaps 24 bodies larger than 100 kilometers, and hundreds of smaller ones. Each had its own orbit, its own composition, its own destiny. Some were in stable orbits that could have lasted for millennia. Others were in unstable configurations, their paths gradually evolving toward inevitable collision. I chose to follow one particular moonlet, a body perhaps 500 kilometers across, as it made its final approach to the proto-moon. This moonlet had been in a stable orbit for weeks, but gravitational perturbations from other passing bodies had gradually decreased its angular momentum. With each orbit, it dropped a few kilometers lower, its path becoming more elliptical. The tidal forces on this moonlet were fascinating to observe. As it approached closer to the proto-moon, the difference in gravitational pull between its near and far sides became significant. The moonlet began to deform, stretching into an egg shape with its long axis pointed toward the proto-moon. This deformation created friction within the moonlet, heating it from the inside out. I watched as cracks appeared on the moonlet's surface, glowing red with internal heat. Some of these cracks widened, becoming chasms that revealed the molten interior. Small chunks broke away from the moonlet, creating a temporary ring of debris that spiraled down to the proto-moon's surface ahead of the main body. The final approach took days. Each orbit brought the moonlet closer, the tidal deformation more extreme. By the last few orbits, the moonlet was no longer a solid body, but a loosely bound collection of fragments held in formation by their mutual gravity and the fact that they all followed nearly the same orbit. The moment of contact was almost anticlimactic. The moonlet didn't so much impact the proto-moon as settle onto it, like foam settling onto a wave. The fragments spread across the surface of the magma ocean, creating a temporary bright patch that slowly dispersed as the material mixed with the proto-moon's surface layers. But beneath this gentle surface interaction, more dramatic events were unfolding. The core of the moonlet, denser than the surrounding magma, began to sink. This created a downwelling in the proto-moon's mantle, a column of descending material that would eventually merge with the growing lunar core. The process took hours, but I watched it all, fascinated by the complexity of the fluid dynamics involved. By this time, several months after Theia's impact, the disk had transformed dramatically. Where once there had been billions of particles, now there were perhaps 100 significant bodies and a diffuse halo of dust. The largest moonlet had grown to nearly 3,000 kilometers across, 3/4 the size of our modern moon. It had become the gravitational king of the disk, its influence extending across the entire Earth-Moon system. This proto-moon was a fascinating world. Its surface was entirely molten, an ocean of magma that glowed with its own heat. But it wasn't uniformly hot. Convection cells brought hotter material up from the interior, while cooler material sank, creating a constantly changing pattern of bright and dim regions. From Earth, it would have looked like a giant ember in the sky, pulsing with internal fire. The remaining large moonlets orbited in a complex dance around this proto-moon. Some were in resonant orbits, protected temporarily from collision. Others followed chaotic paths that brought them alternately close and far. Each encounter transferred angular momentum, gradually destabilizing the entire system. I remember the merger of the last major moonlet with the proto-moon. This moonlet, perhaps 800 kilometers across, had survived longer than most by virtue of its distant circular orbit. But even it couldn't escape forever. Gravitational perturbations from Earth slowly decreased its orbital velocity, causing it to spiral inward over the course of weeks. The approach was agonizingly slow from a human perspective, but blindingly fast in cosmic terms. Each orbit brought the moonlet a few kilometers closer. Its surface began to deform from tidal forces, bulging toward the proto-moon. Cracks appeared, glowing with heat from the tidal flexing. Small chunks broke away, creating a temporary ring around the moonlet itself. When the two bodies finally touched, it was at a relative velocity of just a few hundred meters per second. The moonlet settled onto the proto-moon's surface like a droplet of water merging with a pond. The impact sent ripples through the magma ocean, waves of molten rock racing around the entire circumference of the growing moon. Over the following hours, the moonlet sank into the proto-moon's surface, its material spreading and mixing. The added mass and angular momentum caused the moon to spin faster, flinging some surface material back into orbit. This created a temporary ring around the moon itself, a miniature echo of the original debris disk. With each merger, the moon grew closer to its final size. But growth was only part of the story. The moon was also differentiating, separating into layers according to density. Iron and other heavy elements sank toward the center, forming a small metallic core. Lighter silicates floated upward, beginning to form what would eventually become the lunar mantle and crust. The heat from all these collisions, combined with radioactive decay, kept the moon molten for extended periods. This was crucial for its evolution. In a solid body, materials would remain mixed where they formed. But in a liquid, gravity could sort them efficiently, creating the layered structure we see today. And there it was, our moon, still glowing, still accumulating the last wisps of orbiting debris, but recognizably the companion that would orbit Earth for billions of years to come. But let me not gloss over this moment of recognition, for it represents a profound transformation. What had begun as two separate worlds, each with its own history spanning millions of years, had become, through violent alchemy, a third body, similar to both parents yet unique in its own right. This was not simply Theia reborn, nor a piece of Earth flung into orbit, but something genuinely new. A hybrid world that carried within it the memories of both its progenitors. The moon at this moment was roughly 90% of its current size, about 3,100 kilometers in diameter. It glowed with the heat of its assembly, surface temperatures exceeding 1,500 Kelvin across most of its surface, hotter still, where recent impacts had added fresh energy. From Earth, it would have appeared as a small sun, bright enough to cast shadows at night, warm enough to be felt on exposed skin from 250,000 kilometers away. But this was no uniform ball of glowing rock. Even in these early hours of its existence as a unified body, the moon showed complexity. The surface brightness varied, revealing the pattern of convection cells in the magma ocean beneath. Brighter regions marked where hot material from the deep interior had risen to the surface. Darker areas showed where cooled material was sinking back down, completing the convective cycle. Impacts continued to pepper the surface, though at a much reduced rate compared to the violent early days. I watched one such impact, a moonlet perhaps 10 kilometers across that had somehow survived until now. It approached from a highly elliptical orbit, accelerating as it fell toward the moon. The impact released energy equivalent to millions of nuclear weapons, creating a transient crater in the magma ocean that sent waves rippling outward for thousands of kilometers. But unlike impacts on a solid surface, this crater didn't persist. The magma ocean flowed back, filling the depression in minutes. The only lasting effect was a locally higher temperature and a slight enrichment in whatever elements the impactor had carried. Over millions of such impacts, the moon's composition would be fine-tuned, averaging out local variations and creating the relatively homogeneous body we know today. The internal structure of the newborn moon was fascinating to observe. Using my ability to perceive matter at all scales, I looked deep beneath the glowing surface. The core, small compared to Earth's, but still substantial, was a swirling mass of liquid iron and nickel, with traces of sulfur and other elements that lowered its melting point. This core was generating a magnetic field through dynamo action, though weaker than Earth's, and destined to fade as the moon cooled. Above the core, the mantle was stratified by composition rather than temperature. The deepest regions were enriched in dense minerals like olivine and pyroxene. Higher up, where pressures were lower, different mineral phases were stable. The magma ocean itself, the upper few hundred kilometers, was the most evolved in composition, enriched in elements that didn't fit well into the crystal structures of the solidifying minerals below. I spent time studying the chemistry happening in this magma ocean, for it would determine much about the moon's future surface. As the ocean cooled, the first minerals to crystallize were those with the highest melting points: olivine and pyroxene, rich in magnesium and poor in iron. These minerals were denser than the liquid they formed from and sank, carrying their chemical signature to the deep interior. But not all minerals sank. Plagioclase feldspar, rich in calcium and aluminum, was less dense than the magma ocean. When it crystallized, it floated, accumulating at the surface like a mineralogical scum. This would become the lunar highlands, the light-colored regions that give the moon its mottled appearance. The process was just beginning, but already I could see patches where the floating plagioclase was starting to form a primitive crust. But the moon's birth was far from complete. What existed now was a molten world, a sphere of liquid rock glowing with the heat of its violent formation. The real moon, the moon we know, with its ancient highlands and dark Maria, would take millions more years to fully form. In those first years, the moon was much closer to Earth than it is today. It orbited at perhaps 25,000 kilometers, less than a tenth of its current distance. At this distance, it appeared enormous in Earth's sky, when the atmosphere cleared enough to see it. 16 times larger than our modern moon, it dominated the heavens, a glowing orange disk that never showed phases because it was hot enough to shine with its own light. The tides it raised on Earth were beyond imagination. These weren't water tides. Earth's surface was still mostly molten rock. These were tides in the magma ocean itself, bulges of liquid rock hundreds of meters high racing around the planet every few hours. The friction from these tides transferred angular momentum from Earth's rotation to the moon's orbit, gradually pushing the moon farther away while slowing Earth's spin. I spent years watching the moon's surface evolve. The magma ocean didn't solidify uniformly. The first solid rocks formed in areas of localized cooling, perhaps where particularly volatile pore material accumulated. These protocontinents of moon rock floated on the magma ocean like icebergs, colliding and merging, breaking apart and reforming. The chemistry happening in this magma ocean was fascinating. As minerals crystallized, they concentrated certain elements and excluded others. The first minerals to form were rich in magnesium and poor in iron. Being less dense than the liquid they formed from, they floated, accumulating into the first lunar crust. This process, called fractional crystallization, gradually changed the composition of the remaining liquid. Each mineral that formed and floated away left the magma ocean enriched in elements that didn't fit into those mineral structures. Iron, titanium, and incompatible elements became concentrated in the residual liquid. The moon's surface during this period was a constantly changing landscape. Solid crusts would form, thicken, then founder and remelt, as convection brought fresh heat from below. Impact from the remaining debris in Earth orbit added new material and new heat, locally remelting areas that had begun to solidify. I remember watching the formation of the first permanent crust. It began in the lunar far side, the hemisphere facing away from Earth. Here, away from the tidal heating caused by Earth's proximity, cooling was more efficient. A raft of light-colored rock, rich in calcium and aluminum, formed and thickened until it was too buoyant to sink back into the magma ocean. This primordial highland crust spread slowly, year by year, across the moon's surface. It wasn't a smooth process. The crust would advance, then retreat as fresh impacts or volcanic eruptions broke through. But gradually, inevitably, solid rock claimed more and more of the moon's surface. The moon's gravity reached out, capturing the last of the debris, sweeping Earth's orbital neighborhood clean. Together, Earth and Moon began their eternal waltz, two partners born from chaos, now locked in gravitational embrace. This cleaning process was gradual but thorough. The Moon acted as a gravitational shepherd, its influence extending far beyond its physical surface. Debris in certain orbits would be destabilized by the Moon's gravity, either falling to Earth or Moon, or being ejected from the system entirely. I watched as the last major debris fields dissipated. Some material formed temporary Trojan points, accumulating at the gravitationally stable Lagrange points in the Earth-Moon system. But even these collections were unstable over long timescales, gradually dispersing as solar perturbations and the changing Earth-Moon distance altered the dynamics. The relationship between Earth and Moon was already beginning to shape both worlds. The Moon's gravity stabilized Earth's axial tilt, preventing the wild wobbles that would have made climate chaotic. Earth's gravity gradually locked the Moon's rotation, forcing it to always show the same face to its parent planet. But perhaps most importantly, the Moon began to stir Earth's interior. The tidal heating from the Moon's gravity helped maintain convection in Earth's mantle, driving plate tectonics and the cycling of materials between surface and interior. This process would prove crucial for maintaining Earth's habitability over geological time. As I watched these two worlds begin their long journey together, I couldn't help but marvel at the chain of events that brought them to this point. A chance encounter between two young planets. A collision at just the right angle and velocity. A disk of debris that could have dispersed, but instead gathered into a single, large moon. So many things had to go exactly right for this outcome. The young Earth-Moon system was unlike anything else in the inner solar system. Mercury and Venus had no moons. Mars would later capture 2 small asteroids, but these were tiny compared to their parent planet. Only Earth had a true companion, a moon so large relative to its planet that some would later call the Earth-Moon system a double planet. This unique configuration would have profound effects on Earth's evolution. The moon's presence would create complex tides when Earth finally developed oceans. These tides would create a unique environment at the boundary between land and sea, perhaps contributing to the evolution of life. The moon would light Earth's nights, allowing nocturnal activity. It would serve as a stepping stone for a species that would one day venture beyond their home world. But all of that lay billions of years in the future. For now, there were just 2 cooling worlds, locked in their gravitational embrace, slowly settling into the rhythms that would govern their dance for eons to come. In the millions of years that followed, I watched Earth and Moon evolve together, each shaping the other in ways profound and subtle. The Moon's initial orbit was so close to Earth that it completed a full revolution in just a few hours. From Earth's surface, if you could have found solid ground to stand on, you would have seen the Moon race across the sky, rising and setting multiple times in what we would call a day. But Earth's day was also much shorter then, the planet spinning rapidly from the angular momentum added by Theia's impact. This close proximity created tides of unimaginable power, not tides in water. Earth had no oceans yet, but tides in the molten rock itself. I watched as bulges of liquid rock, hundreds of meters high, raced around Earth's equator, following the Moon's orbital motion. Where these tidal bulges passed, the crust, what little had begun to solidify, cracked and remelted, keeping Earth's surface in constant flux. The energy dissipated by these tides was enormous. It heated both Earth and Moon, prolonging their molten states. But more importantly, it transferred angular momentum from Earth's rotation to the Moon's orbit. Each tidal cycle moved the Moon a tiny bit farther away, while slowing Earth's rotation by an equally tiny amount. These changes were imperceptible on human timescales, but dramatic over geological time. I remember calculating the rate of change in those early days. The Moon was receding at meters per year, thousands of times faster than today's rate of 3.8 centimeters. Earth's day was lengthening by hours per million years. The system was evolving rapidly toward a more stable configuration. As the Moon moved farther from Earth, its appearance in the sky changed dramatically. The huge orange disk that had dominated the sky immediately after formation gradually shrank and cooled. The surface began to solidify, starting with isolated rafts of crust that formed in areas of localized cooling. These crustal fragments were fascinating to watch. They would form, thicken, then often founder and remelt as convection brought fresh heat from below. The first permanent crust formed on the Moon's far side, the hemisphere always facing away from Earth. Here, without the tidal heating caused by Earth's proximity, cooling was more efficient. I watched as a small patch of light-colored rock formed and didn't remelt. Over months and years this patch grew, spreading outward like ice forming on a pond. This early crust was a northocite, a rock composed almost entirely of plagioclase feldspar. It formed through a process called fractional crystallization. As the magma ocean cooled, the first minerals to crystallize were dense and sank, but plagioclase was less dense than the liquid it formed from, so it floated, accumulating at the surface like a rocky scum. The growth of this crust wasn't smooth or uniform. Sometimes large areas would solidify rapidly, only to be broken up by a convective overturn from below. Impact from the remaining debris in Earth orbit added new material and new heat, locally remelting areas that had been solid for centuries. But overall, the trend was toward a cooler, more solid moon. Earth's evolution during this period was equally dramatic. The energy from Theia's impact had completely remixed the planet, erasing any previous differentiation. But now, as the planet cooled, it began to separate once again into distinct layers. Iron and nickel sank to form the core. Silicates formed the mantle, and the lightest materials began to accumulate at the surface, forming the first continental crust. The atmosphere during this period was unlike anything in Earth's modern experience. The impact had vaporized any primordial atmosphere, replacing it with rock vapor and gases released from the planetary interior. As temperatures dropped, this atmosphere evolved. Water vapor began to condense, not yet as rain, but as a dense fog that shrouded the entire planet. Other gases, carbon dioxide, methane, ammonia, created a greenhouse effect that slowed the cooling process. I remember the first time it rained on Earth after the impact, perhaps a century after the collision, in a localized area where atmospheric conditions were just right. Water droplets grew large enough to fall. They never reached the surface. The ground was still far too hot, but evaporated in midair, creating virga, those curtains of rain that hang from clouds but never touch the ground. As Earth's surface temperature dropped below the boiling point of water at the surface pressure, these rain events became more common. But this wasn't gentle rain. The temperature difference between the upper atmosphere and the surface created violent convection, spawning storms of incredible intensity. Lightning was near continuous, providing a source of energy that would later prove important for the synthesis of complex organic molecules. The interplay between Earth and Moon during this period extended beyond the obvious gravitational effects. Both worlds were magnetically active, their liquid metallic cores generating magnetic fields through dynamo action. These fields interacted in complex ways, sometimes reinforcing each other, sometimes cancelling out. The result was a constantly changing magnetic environment that affected everything from atmospheric retention to the paths of charged particles in near-Earth space. The Moon's recession from Earth was slow but inexorable. Each year, it drifted a few centimeters farther away, its orbital period lengthening incrementally. What had begun as a month of just a few days stretched to a week, then 2 weeks, gradually approaching the 28-day cycle we know today. As the Moon receded, its appearance in Earth's sky changed dramatically. The enormous orange disk that had dominated the sky after formation gradually shrank and cooled. The surface solidified completely, creating the two-toned appearance we see today. Bright highlands formed from the original crust, and darker regions where later impacts excavated material from deeper layers. Earth, too, was transforming. The energy from Theia's impact, combined with heat from radioactive decay, had completely melted the planet, but now it began to cool and differentiate. Iron sank to the core, silicates formed the mantle, and the lightest materials began to form the first continental crust. The atmosphere during this period was alien beyond description. The impact had vaporized Earth's original atmosphere, replacing it with a heavy blanket of rock vapor and volatile compounds. As the surface cooled, this atmosphere evolved. Water vapor began to condense, not yet as rain, but as a dense fog that shrouded the entire planet. I remember the first time the fog cleared enough to see the Moon from Earth's surface. It was a revelation. The moon no longer glowed with its own heat, but shone with reflected sunlight. For the first time, it showed phases, waxing and waning as it orbited Earth. The terminator, that line between lunar day and night, revealed the texture of the surface. Mountains and valleys, plains and highlands. The late heavy bombardment was yet to come. That period when the outer planets migrated and disturbed billions of asteroids and comets, sending them raining down on the inner solar system. But already, impacts were shaping both Earth and Moon. Each major impact added new material, new heat, new possibilities. On the Moon, these impacts created the features we see today. The largest formed the Great Basins: Imbrium, Serenitatis, Crisium, Orientale. Later, these basins would flood with lava, creating the dark Maria, or seas, that give the Moon its familiar face. But that was still millions of years in the future. For now, they were just enormous craters, their floors fractured and their rims mountainous. Earth's impacts had different effects. With active geology driven by internal heat and lunar tides, impact craters didn't last long. They were eroded, buried, recycled through the constant churn of plate tectonics. But each impact added material to Earth, including water and organic compounds that would prove crucial for life. The dance between Earth and Moon was stabilizing into the pattern that would persist for billions of years. The Moon's orbit was becoming more circular, its inclination settling into a gentle tilt relative to Earth's equator. Tidal locking was nearly complete. The Moon's rotation had slowed until it matched its orbital period exactly. I've carried this memory for billions of years. The birth of our Moon, that faithful companion that would witness all of Earth's history to come. From the first spark of life in primordial seas to the footprints of astronauts on lunar soil. This memory is not merely a record of events, but a living thing that has grown and deepened with each passing eon. Every time I return to it, I discover new details, new connections, new moments of beauty within the chaos. The birth of the Moon was not a single event, but a cascade of countless events, each one necessary, each one perfect in its own way. I remember specific moments with crystal clarity, the exact shade of orange-red that Theia glowed in those final moments before impact, the particular pattern of cracks that spread across her surface as tidal forces tore her apart, the way the first droplets of condensing rock in the debris disk caught the sunlight, sparkling like diamonds against the black of space. These details are etched into my consciousness with a permanence that transcends normal memory. But beyond the visual memories are the more subtle sensations. The feeling of gravitational waves passing through space as two worlds collided. The electromagnetic chaos of a billion lightning bolts crackling through ionized gas. The slow, patient pull of gravity gathering scattered debris into larger bodies. The rhythmic pulsing of tidal forces as the early Moon raced around Earth every few hours. I've watched civilizations rise and fall, seen species evolve and go extinct, witnessed continents drift across Earth's surface like slow-motion ships. But nothing compares to the raw, primal drama of the Moon's birth. It was creation through destruction on a scale that dwarfs all human experience, yet it followed the same physical laws that govern falling apples and ocean tides. Over the billions of years since, I've seen how this violent birth shaped everything that followed. The Moon's presence stabilized Earth's axial tilt, preventing the wild climate swings that would have made complex life difficult or impossible. Its tides created unique environments at the margins between land and sea, laboratories for evolution that may have accelerated the development of life. Its light allowed nocturnal activity, opening new ecological niches that drove evolutionary innovation. I've watched as primitive microorganisms first sensed the moon's pull, developing daily and monthly rhythms that persist in life to this day. I've seen the first eyes evolve partly to take advantage of moonlight for navigation and hunting. I've observed as early humans looked up at the moon and wondered, creating the first mythologies, the first calendars, the first dreams of worlds beyond Earth. And I was there when humans finally returned to the moon, not as cosmic debris, but as conscious explorers. I watched as they bent down and picked up rocks that I had seen form 4.5 billion years earlier. In those moon rocks, scientists would read the story I've just shared with you. The evidence of the giant impact, the crystallization of the magma ocean, the bombardment that followed. But scientific understanding, crucial as it is, captures only part of the truth. The equations and models tell us how the moon formed, but they can't convey the majesty of worlds colliding, the patient beauty of gravity gathering debris into spheres, the profound interconnectedness of Earth and Moon as they began their eternal dance. These deeper truths require memory, imagination, and the willingness to see ourselves as part of the story rather than mere observers of it. The moon would be there for all of it. When the first life forms emerged in Earth's young oceans, the moon's tides would help concentrate chemicals in tidal pools, creating natural laboratories for evolution. When photosynthesis evolved and began to oxygenate the atmosphere, the moon would watch the planet transform from a rusty red to blue and green. During the great ice ages, when glaciers covered much of Earth's surface, the moon's gravitational pull would continue its patient work, stirring the oceans and atmosphere. When life exploded in diversity during the Cambrian, creatures would evolve eyes partly to see by the moon's light. When plants colonized the land, their reproductive cycles would synchronize with lunar phases. The dinosaurs would hunt and nest by moonlight. Early mammals would become nocturnal to avoid predators, developing enhanced night vision to navigate by lunar illumination. When flowering plants evolved, many would time their blooming to lunar cycles, opening their petals to nocturnal pollinators under the full moon's light. And eventually, conscious minds would emerge that could look up at the moon and wonder. They would create myths and legends about the silver disk in the sky. They would use its phases to mark time, creating the first calendars. They would notice its connection to the tides and begin to understand the invisible forces that govern the cosmos. The moon would inspire poetry and art, science and exploration. It would become a symbol of mystery, of unattainable beauty, of the vastness beyond Earth. And finally, it would become a destination. Footprints in lunar dust would mark humanity's first steps beyond their home world, the beginning of a journey that might one day take Earth's children to the stars. All of this lay encoded in that primordial collision, in Theia's sacrifice and Earth's transformation. The moon, born from chaos, would become the silent witness to order emerging from entropy, complexity arising from simplicity, consciousness blooming from unconscious matter. As I drift through time, carrying these memories, I'm struck by the profound interconnectedness of events. Without Theia's impact, Earth might have remained a smaller world, with a thicker atmosphere, perhaps more like Venus. Without the moon, Earth's axis would wobble chaotically, creating wild climate swings that might have prevented complex life from evolving. Without lunar tides, the transition from sea to land might have happened differently, or not at all. The moon is not just a companion, but a co-creator of Earth's story. Born in violence, it became an agent of stability. Created from destruction, it enabled creation. a dead world itself, it helped make Earth more alive. When you look up at the moon tonight, if you choose to, remember that you're seeing Earth's child, born from the planet beneath your feet. Every element in the moon once existed here, part of the same world that now supports your life. Think about what that means. The calcium in lunar highlands might once have been part of Earth's primordial crust. The iron in the moon's small core might have originated deep in Earth's mantle, or perhaps came from Theia's heart. The oxygen bound in lunar minerals is the same oxygen that would later fill Earth's atmosphere and your lungs. We are all made of star stuff, as Carl Sagan reminded us, but we and the moon share an even more intimate connection. We are made of the same star stuff, processed through the same planetary furnace, separated by cosmic violence but forever linked by gravity and history. When you see the moon rise tonight, you're watching a piece of Earth ascending into the sky. When moonlight falls on your face, you're being touched by reflected sunlight that has first touched a world made from your world. The moon is not alien or other. It is family, in the most literal sense. And consider this: the moon you see tonight is still evolving, still changing, though too slowly for human eyes to perceive. It continues to recede from Earth at about 3.8 centimeters per year, about the rate your fingernails grow. In 1 billion years, it will be too distant to create total solar eclipses, those perfect alignments that have awed humans throughout history. But for now, for your lifetime and countless lifetimes to come, the moon remains our faithful companion. It will continue to light dark nights, raise tides in Earth's oceans, and inspire wonder in all who take the time to look up and contemplate their place in the cosmos. The story I've shared with you tonight, the memory of the moon's birth, is written in every lunar rock, encoded in the Earth-Moon orbital dynamics, preserved in the compositions of both worlds. Scientists have read this story in Apollo samples, in computer simulations, in the physics of planetary formation. But knowing the facts is different from experiencing the memory. Through my eyes, you've witnessed worlds colliding and new worlds forming. You've felt the heat of impact, seen the dance of debris, watched as chaos transformed into order. You've experienced deep time not as abstract numbers, but as lived experience, memory made manifest through words and imagination. This is my gift to you, the memory of the moon's birth, preserved across 4.5 billion years and shared in this quiet moment. May it deepen your appreciation for the silver companion that graces our skies. May it remind you that even the most violent changes can lead to beauty and stability. And may it help you sleep tonight, knowing that you rest on a world perfectly partnered, gracefully dancing with its celestial child through the vastness of space. Rest well, dear traveler. The moon watches over your sleep as it has watched over Earth since its birth. And in your dreams tonight, perhaps you'll dance among the forming worlds, witnessing again the cosmic ballet that gave us our companion in the dark. As you settle into sleep, let me paint one final scene for you. A vision of the moon as it appears tonight, carrying within it the memory of its violent birth. When you see the moon's familiar face, you're looking at a fossilized record of the solar system's youth. Those dark maria, the seas of ancient lava, filled impact basins that formed during the late heavy bombardment. The bright highlands preserved the original crust, formed from the magma ocean that covered the moon in its infancy. Every crater tells a story. The newest ones, with their bright rays stretching across the surface, speak of recent impacts. Recent in geological terms, meaning millions of years rather than billions. The oldest craters, almost erased by eons of smaller impacts, date back to when the solar system was still settling into its current configuration. But beneath this battered surface lies the deeper story we've shared tonight. Core samples brought back by Apollo astronauts revealed the chemical signatures of the giant impact, the mixing of Earth and Theia materials, the evidence of the magma ocean, the fractional crystallization that separated the moon into layers. In every grain of lunar dust lies encoded the story of worlds colliding and new worlds being born. The moon you see tonight is not static but dynamic, though its changes occur on timescales that dwarf human experience. It still recedes from Earth, still slows our planet's rotation. Moonquakes still occur as the lunar interior adjusts to the changing tidal forces. The surface still receives impacts from meteoroids, each one adding another chapter to the story written in craters and dust. And what of Earth? Our planet too carries the scars of that ancient collision, though they're harder to see. The Pacific Ocean Basin, some scientists suggest, might be the last remaining trace of the impact site, though plate tectonics has long since erased any direct evidence. The composition of Earth's core, enriched in certain elements brought by Theia, affects the magnetic field that protects us from solar radiation. The length of our day, the stability of our seasons, the very existence of tides, all these trace back to that moment 4.5 billion years ago, when two worlds met and transformed each other. We live on a planet shaped by cosmic collision, accompanied by a moon born from chaos. This is our heritage, written in stone and orbit, preserved in the dance that continues tonight above your head. So as you drift into dreams, remember that you are part of this story. The atoms in your body have been on an incredible journey, formed in the hearts of stars, scattered through space by supernovae, gathered into planets, possibly exchanged between Earth and Theia during their collision, cycled through Earth's interior and surface, through oceans and atmosphere, through countless living things, to arrive here, now, as you. You are not separate from this cosmic story but woven into it, as integral as any planet or moon. When you look at the moon, you're not seeing something other, but something kindred. A family member whose story is intertwined with yours across billions of years. This kinship extends to everything. Every rock, every drop of water, every breath of air connects you to the deep history of worlds. Let this knowledge settle into your bones as you settle into sleep. You rest on a world with a story more dramatic than any fiction, more beautiful than any poetry. You are cradled by a planet that survived cosmic collision and emerged transformed, watched over by a moon that preserves the memory of that transformation. In your dreams tonight, perhaps you'll find yourself back in that primordial time, floating among the debris, watching as chaos transforms into order. Perhaps you'll ride a droplet of molten rock as it journeys from impact plume to lunar surface. Perhaps you'll witness the first sunrise on the newly formed moon, painting its cooling surface in shades of gold and silver. Or perhaps you'll simply rest, deeply and peacefully, knowing that you've touched the deep past through story and imagination. You've traveled billions of years without leaving your room, witnessed the birth of worlds without opening your eyes. This is the gift of consciousness, the ability to experience times and places beyond our immediate reach, to expand our awareness beyond the confines of the present moment. The moon continues its orbit as you drift towards sleep, following the same physical laws that governed its formation. Gravity and momentum, angular momentum and tidal friction. These forces continue their patient work, just as they have every night for billions of years. There is profound peace in this continuity, this reliability of cosmic motion. So rest now, carried by the turning earth, watched by the faithful moon, surrounded by the vast love of a universe that transforms violence into beauty, chaos into order, collision into companionship. Your sleep is part of this cosmic dance, a moment of stillness in the great movement of worlds. Sweet dreams, fellow child of the cosmos. May your sleep be as deep as time, as peaceful as the moon's silent orbit, as refreshing as the first rain on the cooled earth. And may you wake tomorrow with a renewed sense of wonder at the cosmic story in which we all play a part. The Chrononaut's voice fades now, but the story continues. In the moon's faithful orbit, in Earth's steady turning, in your peaceful breathing as you join the great rhythm of worlds at rest. Sleep well, knowing you are home on a planet with a story written in the stars, forever dancing with its celestial child through the vastness of space and time. Good night, dear traveller. Until we meet again in the depths of time. This is the Chrononaut, your guide through Earth's memories, bidding you the sweetest of dreams under the watchful eye of our newborn moon. As you drift towards sleep, let your mind float free from the constraints of the present moment. Perhaps you'll find yourself in that ancient time, 4.5 billion years ago, watching as Theia approaches through the star-filled sky. Perhaps you'll stand on young Earth's molten surface, feeling the gravitational pull of our approaching sister world. Or perhaps you'll drift among the debris ring, watching as countless fragments slowly gather into the moon we know and love. You might witness the first permanent crust forming, or see the first time Earth rose over the lunar horizon. A blue and white marble in the black sky, beautiful beyond description. These memories I've shared are now part of you, woven into your consciousness like threads in a tapestry. They connect you to the deep past, to the very origins of the world you inhabit. When you wake tomorrow and see the moon setting in the western sky, you'll see it with new eyes, not just as a distant light, but as a family member, a piece of home that ventured into space and decided to stay close by. The universe is vast and often incomprehensible, but some stories are simple at their heart. Two worlds met. They transformed each other through their meeting, and from their violent embrace came a partnership that would last for billions of years. It's a love story, in a way, written in gravity and stone, played out over cosmic time. So close your eyes now, if they aren't already closed. Feel yourself sinking into comfort, into peace, into the welcoming embrace of sleep. Know that above you, whether visible or not, the moon continues its eternal watch, the same moon born from chaos, the same moon that has witnessed every moment of Earth's history, the same moon that will be there tomorrow and for countless tomorrows to come. Sweet dreams, fellow traveller of time. May your sleep be as peaceful as the moon's silent orbit, and may you wake refreshed, carrying within you the wonder of worlds colliding and new worlds being born. As you continue to settle deeper into rest, let me share one more gift, a vision of the far future, billions of years from now, when the dance between Earth and Moon reaches its final phase. The moon will have receded so far that it appears smaller than the sun, no longer able to create total solar eclipses. Earth's rotation will have slowed until a day lasts as long as a month, with the same face of Earth always pointing toward the moon, just as the moon now always shows us the same face. In that distant future, Earth and Moon will have achieved perfect synchronization, rotating and revolving as one system, locked in an eternal gaze. The tides will have ceased, the transfer of angular momentum complete. It will be a quiet ending to a dance that began in violence, a peaceful conclusion to a story that started with worlds colliding. But that ending is billions of years away. For now, for countless generations to come, the dance continues. Each night, the moon rises and sets. Each month, it waxes and wanes through its phases. Each year, it drifts a little farther away, too slowly for any human lifetime to notice, but inexorably over geological time. You are privileged to live in the epoch when the moon is at just the right distance to create perfect solar eclipses, when the dance is still dynamic, when the tides still pulse with the rhythm of cosmic forces. You live in the sweet spot of Earth-Moon history, able to witness and appreciate a system still evolving, still changing, still writing new chapters in its ancient story. So as you drift into sleep tonight, remember that you're not just an observer of this cosmic dance, but a participant. The moon's gravity tugs at every atom in your body, just as it tugs at the oceans. Your presence on Earth, minute as it might seem, affects the planet's rotation and thus the Earth-Moon system. You are part of the dance, part of the story, part of the ongoing transformation that began 4.5 billion years ago. In your dreams, perhaps you'll feel this connection more directly. Perhaps you'll sense the moon's pull not as an abstract force, but as a gentle hand, guiding you through the night. Perhaps you'll feel Earth's rotation not as motion, but as a slow waltz, carrying you through space with grace and purpose. Perhaps you'll understand, in that deep way that only dreams can teach, that you are not separate from the cosmos, but woven into its very fabric. The story I've shared with you tonight will continue long after these words fade. It will continue in the moon's faithful orbit, in the tide's eternal rhythm, in the slow evolution of worlds locked in gravitational embrace. But it will also continue in you, in your dreams tonight, in your waking thoughts tomorrow, in the new way you'll see the moon, whenever you glance up at the night sky. For you now carry within you the memory of the moon's birth, not as second-hand knowledge, but as lived experience. Through the alchemy of story and imagination, you've witnessed what no human eyes could see. You've felt the approach of Theia, experienced the moment of impact, floated among the forming debris, watched as chaos transformed into the serene silver disk that graces our nights. This is the true gift of consciousness, the ability to transcend the limitations of our brief lives and touch the deep past, to expand our awareness beyond the narrow confines of direct experience. Through story, we become time travelers. Through imagination, we become witnesses to wonders beyond our physical reach. Through memory, even borrowed memory, we connect with the vast sweep of cosmic history. So rest now, enriched by this ancient memory, cradled by a planet that survived cosmic catastrophe, watched over by a moon born from that very catastrophe. Let the knowledge of deep time settle into your bones, bringing perspective to whatever troubles might have followed you to bed. Your concerns, whatever they might be, are held within a story so vast, so ancient, so filled with transformation, that they cannot help but be transformed themselves. The moon continues its orbit as you sleep, following laws of physics that have operated without fail for billions of years. There is deep comfort in this cosmic constancy, this universal reliability. The same forces that gathered scattered debris into our familiar moon continue to operate tonight, maintaining the order that emerged from ancient chaos. Until next time, when we journey together to another moment in deep time, this is the Chrononaut, bidding you the sweetest of dreams. Sleep well, knowing you rest on a world with a story written in the stars. A story of transformation, of partnership, of endless dance between Earth and Moon, Let that cosmic lullaby carry you into the deepest, most restful sleep. Good night, dear traveller. Until we meet again in the depths of time. This is the Chrononaut, your guide through Earth's memories, bidding you the sweetest of dreams under the watchful eye of our newborn moon. May your sleep be filled with visions of forming worlds, and may you wake tomorrow with the wonder of creation still glowing in your heart. The moon watches over you, as it has watched over Earth since its violent birth became a gentle guardianship. Rest in that ancient protection. Sleep in that cosmic embrace. Dream in the safety of a universe that transforms chaos into beauty, violence into grace, collision into companionship. The story ends, but the dance goes on. Sweet dreams, fellow dancer in the cosmos. Sweet dreams, end of recording.